Hello everyone. So I'm recording this video to address a certain topic that is not covered if you're watching this at the time of recording, it will not be on your midterm. The time of recording being the coronavirus semester. However, this is a very useful topic that I want to cover because it might still show up on your homework. However, more importantly, it's an important topic in programming in general that will come to be useful to you outside of just not just functional programming, but in many programming styles. So, and that topic is tuples. So, let's do this. So first we start this off. So what is a tuple? Let's start with that. So, tuple is a way to contain and transport / carry different types of data. Okay. So why do we need this? So for example, this can only contain data of the same type. So for example, I can contain a person's name. So I can say, okay, I have your name, I have someone else's name, I have a third person's name. Okay. Or you can contain, like, let's say, numbers, like that. However, list arrays, typically in a lot of programming languages, cannot contain different types. So for example, there's no way I can in a list have John and his bank balance. I can't connect these two like that because these are two different types. And the same goes for many languages. That's where tuples come in handy. So if I want to put say James and his account balance in here, do James, and then I could do account balance for him. I could do it like this. Now this works because tuples allow you to have any different type inside of them. So this is a string plus an integer. So that's the type of this tuple. So tuples are, their strength is that they can contain many different types and just hold them together. And they're fairly accessible. Now when you're studying C++ or Java, and even in Clean, later you encounter a thing called structures, or in Clean they're called records, which will also serve a similar purpose. You can contain different types and whatnot. And you'll see, and people will be like, okay, why don't we use structs instead of tuples? And I'll show you in a moment what the advantages of tuples are, and disadvantages, but they're advantages. Records I won't really cover here because that's later, and also I want this video to be just about tuples, but I'll mention it briefly. So what's a common use of a tuple? So a common use of a tuple is what's called a dictionary. You can look this up online, programming dictionary, not just dictionary, and you'll see a lot of different versions of dictionaries. They're called dictionaries or maps also, and this is a very useful data structure that's used. So for example, I can say I have a bank, okay? So my bank, okay, is going to be a list of bank accounts. So I'm not even going to write the type here. I'm just going to leave it blank for now. But what's in our bank? So our bank is just going to store a whole bunch of people and how much money they have in their bank account. So I'm going to say I have a person named James, and he has $123, okay? Let's say I want to store another person. I would say his name is Jimmy, and we'll say he's broke. Okay, and we'll say we have Evan here, and he owes the bank a whole load of money. And just we'll just have another person's account. We'll just have another person, John, and he has a good amount to spend, to live on. Okay, so what do we have here? Now we have something. It's a list of things. So these are all the same type. So this is a list of tuples, but the tuples each have a whole bunch of different types to encapsulate two types in them. So what would be the typing on this? The typing would have to be, well, we know the type of each tuple is what? Each tuple is a string combined with an integer. So that's what the type is. And we have a list of them. So we have a list of tuple types that are strings and integers combined, and using this I'll show you guys how we can look up things. And I think this was addressed in lecture with a function called search, which lets you search and find something. So let's say I want to make a function called get account balance. Okay, so what do we want? Let's say we take in a string, so a person's name, someone's name, and I want to give a string back out. Okay, well, in that case, what am I going to do? Well, we'll say get account balance, given a person's name. Okay, what do we want to do? We want to find. Let's assume that no two people have the same name, just for the sake of it, just for the sake of simplicity. So we'll say that we're gonna search for here, and see if we can find his name. Okay, so we're gonna say okay. So let's see. We'll say that given the name, we're gonna say let's do a list comprehension. And we're gonna say that we're gonna take our bank list, so we're say an individual account. So we're gonna pull each individual account out of our bank, okay? And we're going to keep these individual accounts, except what do we want? We only want the ones where the first name matches the name we're searching for. So we're gonna say, okay, let's say individual account. How do we get this first field? Well, there's a nice little function called FST. So we'll say FST of individual account is the same as name. So we're saying that if the first field here, the first one out of these two, if it matches the name, then this will return true. Then we'll put it into the list. Okay, cool. And we can just actually return. We could just return. Well, let's remove the type and let's see what happens. Let's see what happens here. So if we do this, and let me put a start line. So equals get account balance on, let's say, Evan. Okay, here. So what does it return? It returns a list with a single element, my name, and my account balance. Now let's say let's actually add in a duplicate name just for the sake of practice. So let's say we have John, and this John has $42 in his account. So instead of Evan, we'll say John. Okay. So we'll run this again. So now our function returns a list of accounts. We have their names, John and John. So everyone who has the name John, because we took the first of each of these tuples, if they matched, we kept them in the list. And we have their account balances. That's cool. Okay. So now the question is, what if we just want their account balance? Well, maybe we just want to get their. Let's say if we have more than one, we just take the first one. Okay. So we'll take the first one of these two. Okay. So let's say even if we have two of them, we'll just take the first one. Okay. So this just gives us one account. Cool, but we don't want the name in there. Let's say we just want the account balance. Okay, so what we need is to get the second field out of this tuple. So we're gonna say we're gonna get S&D, the second one out of that. Okay, so I'm going to let me just run that, and that gives us 42. So now we can see that get account balance John would basically look up who has the name John by checking the first field against the name here, and then we would put it we would make a list of that, just get the first one and return that. So that's what that is doing. Now this FST here and S&D is great and all, but then there's limitations to that. Now I'll address these limitations a little bit, but let me make a new case where these limitations will come into play. So first, we've already created this, and we can run it just to make sure it works. Cool. Let's say we want to do a function called update account. Okay. So let's say we have a function that does update account. Okay. And this will highlight one of the strengths of a tuple. So we know we have an account which is of string and int tuple. Okay. But let's say we want to do something, and I'll leave the type out just so we can address this there. So let's say we have we updated account, okay? And let's say we want to add at the end of we want to update the account, we want to add a field. We don't want to just say the name and the account number, but we want to add a Boolean that says, okay, whether or not this person qualifies for a loan. Okay, so we can say we have an account. Okay, so how do we create a new tuple? So let's think about this. Okay, so if we have James here, I'm just gonna take the first one and 1, 2, 3. How do I say James 1, 2, 3, and then maybe I want to put a true inside of there? How do I construct this tuple? Well, here we have FST and SND pulling things out of a tuple, so we might want to do that also. So we might want to go, okay, we want to construct things. Okay, so what I'm going to do is I'm going to say I want to construct a tuple of 3 things. So I'm just going to put commas here. The first thing is going to be first of account, because that's the name. So I want to take it out and put it back in. I'm going to take the second of account, take it out and put it back in. And then here, what do I do? Well, I'll say I'll put, we'll check whether or not this second of account, so I'll say S&D of account if it's bigger than 500. So if, let's say if they have more than $500, they qualify for this loan. Okay, so let's try this. Start equals update account on, let's grab James and 1, 2, 3. So we'll just provide one account and we'll update it. Okay, so what happened? We started with this, but we wanted to add new information in while still keeping the original information. So we didn't just want to give out a false. We wanted to add the false to his account information. So how do we do that? We did this. We just took the fields out of the account, put them back in. In fact, we could switch the order if we care to. And then we added another one. We just did a comma and said, okay, we're going to add another thing out here. And this happens to be a Boolean. So the type here is just going to look like this. Well, we know we started with a string, an int, but we wanted to add a Boolean. So this is the type. And we can check that. Yep, that works. Now, there's one thing to note here. This is a little clumsy because FST, SND account 500, it's not really good because one, we're calling this function twice, but also it's hard to read. It's not very conducive. So there's a better way to write this. And this is using the power of pattern matching. So what's pattern matching? We can say, we know we have 2 fields here. We know we have 2 fields. So what I'm going to do is I'm going to pattern match them. So I have 2 fields. I'm going to pattern match the first field into a variable called name. And I'm going to pattern match the second variable into a variable called balance. Like that. What does that mean? So I could then in that case now use name and balance as they are. So if I want to put it back in, I'll put name back here. I'll put balance back here. And the last one was if balance is greater than 500. So now we can check to see if this works, and it does work. So what happens here? And I'm going to suggest to a lot of people this is that if you can use pattern matching for tuples, please do. You don't have to type out name and balance. I'm just doing this to make it excessively clear. A lot of people use X, Y, and Z, A, B, and C. That's fine. You can name them whatever, but it's good practice to name your variables in a way that they actually mean something, so you know what they're talking about. So here we're saying whatever's in here will be stored into name, whatever's in here will be pattern matched into balance, and then we can do a bunch of things with them. So here we just put name and balance back into the new tuple, but here we can use balance to see if it's bigger than 500. And this is actually really good. Why? So the thing about this is that FST and SND, if you guys look it up, these are limited to only tuples of size 2. So if you have a tuple that has 3 elements, like what we are outputting, these tuples that have 3 elements here. So for example, this makes a tuple with 3 elements. As FST won't be able to get you this, and SND won't be able to get you this. So those are very limited to the size of the tuple. Now there are versions of this called FST3, SND3, and THD3 that work on a tuple of size 3. So there are built-in functions that operate on tuples of size 3. However, they fail when you want a tuple of size 4 or a tuple of size 5 or any tuple of size not 2 and 3. So my recommendation, for the sake of ease of typing, understandability, easy to read, just use parametric. So name, balance, like that. And we can do that. In fact, we can do more than just that. So let's say we want to, let's say we have a name. So let's say we have the name here, okay? And let's say the balance, but let's say we want to check anyone who has a 0 balance, okay? So if they have a 0 balance, what are we gonna do? Well, let's say we don't even care about the name. So we can even do this. We can say we don't care what the name is, but if they have a 0 balance, we're gonna rename them as broke bastard. And we're gonna say their balance is 0. Actually, let's be nice. Let's say if they have a balance 0, we'll give them a $100 loan, and we'll just put here false right away. So in that case, we could say, okay, well, we could say start equals update account on Jimmy. Well, I'm gonna do bank 2. So because we know that that's Jimmy. So we can say, okay, well, Jimmy is a broke bastard, but we gave him $100 and he's definitely doesn't qualify for the loan. So you can use pattern matching to do some pretty cool things. Now, keep in mind this is pattern matching, so I couldn't do less than 0. I could only do if it exactly matches 0. So if I wanted to do less than 0, then I would have to do a condition here. So if balance less than 0, then I can do this. So maybe I want to set it to 0. So this is using a combination of pattern matching and guarding. Okay. So there are things that are pretty powerful. So let's say what are things we can do with that. So let's say we want to. So now that we have something that updates an account with whether or not they are eligible for a loan. Well, let's say we want to get the list of everyone in the bank who are eligible for loans and send them an email. Okay, so we're going to say, let's say eligible people. Okay, so what will we do? Well, we'll take the bank. So we'll take the bank. Given the bank, what are we going to do? Well, we're going to just, let's say we just want their names, okay? We don't care what their balance is. We don't even want to keep the fact that they're broke or not. We just want a name, but it's just filtered out based on whether or not they even qualify. Okay, cool. So we'll say we'll have a list of names back up. Okay, so let's do this. So eligible people given our bank. Okay, so what will we do? Well, let's see. Well, first we need to update. So first we see here this bank doesn't have any information on whether or not they're eligible for a loan as the account is stored right now. So first we have to generate that. So let me comment this out just so you can see it step by step. Okay, so and I'll put here result, and I'll do this in a step-by-step manner just so you can see it. So we'll say updated accounts is equal to update account. Well, we want to do it to every account in the bank, so we could just say we'll map it to our bank, and we'll just do result equals updated accounts, just so you guys can see what it looks like. So we'll say start equals eligible people and bank. So what does this look like? So we're just so far as we're doing, it doesn't solve the full problem, but we're just taking the bank. So if you look here, the bank was originally James 123, John 42, Jimmy 0, Evan blah, like that. Okay, we are just updating all of them. So we just took it and updated every essentially bank account with true, false, true, false, true, false. And that was fairly easy. That was just one step. Okay, that's all that this is. So we had a function that did it. We mapped it to the list of banks. Cool. Now, what do we want to do? we want to filter this. So we want to filter this based on whether or not, well, they are valid for that thing. Let's make someone else valid just so we don't only have one person valid for a bank loan. Okay, so let's make James also valid. So we'll run this again. So James will also be valid. So we'll have two people valid for loans. Okay, so we'll do a filter. So we'll say filtered accounts equals, okay. So how are we going to do this? We're going to filter. We're going to have some condition here. I'll write that later. On our updated accounts, what are we going to filter? What's the condition? Well, so filter works by taking each of the elements of the list out and feeding into the condition, and we have to have something that returns a true or false. Okay, so this list is a list of tuples, meaning each element that gets extracted is a tuple of this, this, and this, string, integer, boolean. Okay, so we're going to say given, okay, an account out of there. Okay, well, we don't need to do any operation. We could just get this third one out. So we can say THD3 on account like this. Okay, so let's see what this does. Okay, so if you see here, what it did was it filtered the accounts based on whether or not that last part was true or not. Okay, so if that last part with THD3 was true, it would pull it out. Now, I don't like doing it this way with THD3. As you can remember, as I said, this only works because it's a tuple of 2 or 3 size. If it's bigger, it won't work. So how do we handle it if it's bigger? Well, we use a parametric. So instead of account, what I'm going to do is I'm going to use a parametric. I'm going to say, I don't care what the name is. I don't really care how much they are. I mean, how much they have. I just care about this, this here. So this is the Boolean that we're checking. Okay. So given this pattern match with the first, which is their name, I don't care. Their account balance, I really don't care either. All I need to do is check this account balance, whether or not they are eligible or not. And I'll name it something, status. Okay, let's say their status. I would just return their status. And that's the power of tuples, is I can carry a whole bunch of information, and then I can pattern match based on that to do stuff. And this is actually kind of how things work. Okay, so that was another step. So let's say, but again, as I said before, I didn't want all this information. I just wanted their names. Okay, so let's just get their names. So I say account names is equal to, well, so we have filtered accounts. Okay, so we have that, but we need to get their names out. So, well, we'll just do this whole list building thing. So for, well, let me not do it with a list comprehension. So let's do it with a map. So we'll map something. We'll map something that it gets just the names out. Okay. Well, how would we do this? Well, we know, and I'm going to do this with the parametric. So this is a lambda expression. So we know our thing always has 3 things in it. Okay. We know we want the name, which is always the first thing, but we don't really care about the amount, and we don't really care about the status anymore because we already filtered it. So we don't care about these two. All we want is the name, and all we want to get back is the name. Okay, let's see what happens there. So I'm just going to change result to show us that. Now, there we go. So using this, we are able to extract the names. And this actually kind of shows some of the power of what tuples can do. Notably, this shows one thing that is hard to do with a class or structure or even a record, which is if you want to create a new field, here all you have to do to create a new field is you just literally put a comma and add the new field in. In structs and classes, okay, there is a way to do it dynamically, but it's not as easy to just go, oh, we want to make a new class that just suddenly has a new field to save something else. We want to suddenly transport a new piece of information with this already different set of information. That's not so easy with classes and records and structures. With tuples, it's really easy. I say, well, I have something that's transporting 2 pieces of information. I want to now transport 3 pieces. No problem. Put it in the tuple. That's cool. Here I want to extract the tuple things out. That's cool. Pattern match. Just say, well, don't care about these two. I just check this one. Okay, cool. Now we can do something based on it. This one, pattern match, just on the first one. We don't care about the last two. Cool. We want just the name. And hence we just got just the names. And let me put the type back in and just make sure it works. But yeah, there you go. Now this looks a little long, but really it doesn't have to be that long. So what's another way of writing this? So once you get good at this, you could do it it's pretty powerful, and that it can be pretty short. So what I'm going to do is I'm going to copy paste most of this. So instead of doing that, I can actually do a lot of this in just a list comprehension. So what we're going to do, we're going to say we're going to grab an account out of our bank, okay? We're going to grab an account out of our bank based on the condition that the status of this is true. Well, we're not going to do this THD thing, so we're already just going to do this. We want the name, we care about the name, we don't care about the balance right now, and we care about the status. Okay. So based on status, so if status is true, we keep the name. And now if you look at this one, two, and bank. So now within one line, cannot demand. Oh, I forgot. I needed to update the bank. So we needed to update the bank too. Forgot to do that. So update account on our bank. Oh, we'll map that. So first we map update account on our bank. So we update the accounts. We extract each of that out. Based on the status, we get the name. Okay. There we go. So this is a little less readable than this, but it does show you that the power of tuples is pretty strong, in that really it makes things really fast. So here, and so let's say we didn't want to do this with tuples. So there are ways to do this without tuples. It's just not as easy, because let's say we completely eliminated the tuples. Well, first, it's hard to create some sort of association between the name and the account. So that would have to be done with tuples, but even without that, then we would have to do two lists. So one list would check the status, and one list would check the balance and create a bunch of Booleans, and based on those we would check the name. So it is possible to do it without tuples, but honestly, this is where tuples come into play, because we are associating different types of information. We want to keep them together and carry a bunch of information of different types together. That's when tuples come into play. So if I wanted to keep a name, an account balance, and a status all together and transport it from function to function, you use a tuple for that. And really that's one of the cool things here, is that, okay, they're separated, but we can still use them. Name, status, yep, there we go. And that's kind of really what tuples are in a nutshell. You build tuples by literally just putting parentheses, putting commas, and then say something goes here, something goes here, something other goes here, and another thing goes here. That's how you build a tuple. And now if you want a pattern match, you pattern match equally the same. So if you know it's three things, you go A, B, C. And now some A will be equal to something, B will be equal to other, and C will be equal to another. This is very commonly how tuples work. Now, typically tuples don't involve more than 3 fields, because what you'll see in the real world is that you'll have tuples where, let's say we have a function that will take an IP address. It will take an IP address like that. Am I misspelling? I don't know. I think it's 1D. But you will have an IP address, okay? So the IP address will be some kind of set of numbers, okay? But what will we want? Well, we want maybe we will want usually a tuple that will have some sort of status based on the IP address and a status report, something like this. So that will be in terms of a tuple. So here we use a lot of tuples. Why? For example, here the IP is a bunch of usually IP addresses are a bunch of numbers like 10.0.0.1, for example. But in this case, it's very specifically 4 numbers. So if we just did this as list of integers, we can't control how many integers are there. We can't control that there's only 4. So this would already be a tuple. So this would be something like 1, comma, so this would be something like 10, comma, 0, comma, 0, comma, 1. We could control that it's specifically 4 tuples, tuple of 4 integers. So we could type this as int, comma, int, comma, int, comma, int. That already is one use of tuples. Now, what's another thing we can do? Let's say our status. We want to say it's offline, and then we also want to give a status report. So the status report will contain the IP address. So it will contain 10.0.0.0.1, and then maybe something like it'll contain a name. So we'll say this is node 1 or something like some kind of name. Okay. So this is a very simple one, but so in this case, this would also be again represented in terms of a tuple. So what we would do was, so we would maybe have a Boolean here, so we could say this is false, it's offline. And then here, in the second part of the tuple, we can grab the information we needed. So here, we would have an IP. So the first part will be an IP address, which again is controlled to int, 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 int. And then the second one would just be a string with the status. So here we would essentially have a whole bunch of tuples doing a lot of really good work for us, really. So this would be a Boolean, sorry. And this would be representing the IP using a tuple that controls that we have specifically 4 numbers encapsulated together. And here would be just a string, node 1, something like that. So here I've already demonstrated a few uses of tuples, in that we can, if we send information, we can also control the information. So if for some reason the IP address was given, but there was an extra number at the end for some reason, and we're not supposed to have it, this can reject it because it'll be like, oh, nope, it's not matching what we want. Here we want to return a bunch of information all included together of different types. So we want to include a status, an IP address, which itself is a tuple, and a string. So how do we put all of these together? We use tuples to hold them. And this is the power of tuples. You can contain certain things, you can put certain restrictions, but also have freedom to easily extend them and add different types together. And that is, in essence, tuples in a nutshell. They're actually a fairly simple concept. It's just that you have a bunch of different things together. You have to know how to get things out, either using FST. You can do it using something like THD3, which I used somewhere, but then I deleted it. So you can use FST, SND, or FST3, SND3, THD3 to extract information out of a tuple. I recommend using pattern match so that you can extract them easier. But then other than that, building a tuple is just a matter of sticking things in between parentheses with commas. And that's it. I hope this helped. Please email me or bother me a chat if you have any other questions, and stay safe. Have a good day.